There's something deeply unsettling about looking so far into space that distance stops meaning distance and starts meaning time. Every image captured by the James Webb Space Telescope isn't just a photograph. It's a message. A signal sent billions of years ago. When you look at those glowing galaxies, you're not seeing them as they are. You're seeing them as they were, when the universe was still learning how to exist. And that's what makes this machine different from anything humanity has ever built. It wasn't designed just to see farther. It was designed to see earlier. Long before Webb launched, astronomers had already changed our understanding of reality using the legendary Hubble Space Telescope. Hubble showed us that our galaxy wasn't alone. It revealed black holes at the centers of galaxies. It helped measure the age of the universe itself. But even Hubble had a limit. Because the deeper you look into space, the older the light becomes. And as that light travels across billions of years, something happens to it. It stretches. This effect, known as redshift, pushes ancient light out of the visible range and into infrared. And that's where Hubble begins to fade. So astronomers faced a challenge. If we wanted to see the first galaxies ever formed, we needed a completely new kind of eye. Not just bigger. Not just stronger. But fundamentally different. And that's how Webb was born. But building Webb wasn't just difficult. It was borderline impossible. Because the telescope had to be enormous, over 6 meters wide, yet somehow fit inside a rocket. So engineers did something unprecedented. They made it fold. Not like a simple machine, but like something closer to origami in space. A mirror made of 18 segments. A massive sunshield the size of a tennis court. Delicate systems designed to unfold perfectly, millions of kilometers away from Earth. Because here's the reality, if even one step failed, the entire mission would be lost. And Webb wouldn't just fail quietly. It would become one of the most expensive scientific losses in history. After launch, the telescope began a journey to a point known as L2, a gravitational balance point about 1.5 million kilometers from Earth. Far beyond the moon. Far beyond easy repair. And that distance wasn't chosen by accident. It was chosen for darkness. And more importantly, for cold. Because Webb doesn't just observe light. It observes heat. Infrared astronomy is incredibly sensitive. Even the warmth of the telescope itself could destroy its ability to see distant galaxies. So Webb had to become something extraordinary, a machine colder than almost anything naturally found on Earth. Once deployed, its massive sunshield blocked heat from the sun, Earth, and Moon. On one side, temperatures reached over 80 degrees Celsius. On the other, they dropped to nearly 230 degrees Celsius. That's colder than Antarctica. Colder than most of space environments we interact with. Only at those temperatures could Webb begin its real mission. To detect light that has been traveling for over 13 billion years. Think about that. The photons hitting Webb's mirror today started their journey before Earth existed. Before the solar system formed. Before the Milky Way fully took shape. That's not observation. That's time travel. And the mirror collecting that ancient light? It's unlike anything ever built. Each segment is made from beryllium, chosen because it holds its shape in extreme cold. Then coated in a microscopic layer of gold, not for luxury, but because gold reflects infrared light better than anything else. But even that wasn't enough. Once in space, those 18 segments had to align with absolute precision. Not millimeters. Not micrometers. But nanometers. Engineers spent months carefully adjusting each piece, until the entire mirror acted as one perfect surface. Because if it didn't, and that realization is where the story takes a turn. Because discovering the first galaxies was never supposed to be easy. But it was supposed to make sense. For decades, scientists built careful models of how the early universe evolved. After the Big Bang, matter slowly cooled. Gravity pulled gas into small clumps. Those clumps formed the first stars. And over time, those stars gathered into galaxies. It was a gradual process. Messy. Slow. Predictable. Or at least, that's what we thought. When the James Webb Space Telescope began sending back its first deep field images, astronomers expected to see faint, irregular shapes. Tiny galaxies, just beginning to form. Instead, they found something else. Massive structures. Bright cores. Defined shapes. Galaxies that looked far too developed. Some of them appeared just a few 100 million years after the Big Bang. That's incredibly early. Cosmically speaking, it's like seeing a fully grown city appear moments after the first brick was laid. And that's the problem. According to existing models, there simply wasn't enough time. Not enough time for stars to form. Not enough time for galaxies to assemble. Not enough time for complexity to emerge at that scale. And yet, there they were. At first, scientists were cautious. Maybe the measurements were off. Maybe the distances were miscalculated. Maybe something in the data was misleading. But as more observations came in, the pattern held. Again and again, Webb kept finding galaxies that seemed too old for their age. Too organized for their era. Too advanced for the early universe. Some researchers began calling them impossible galaxies. Not because they couldn't exist, but because they shouldn't. This is where things started to get uncomfortable. Because in science, when observations don't match theory, something has to change. Either the data is wrong, or the theory is. And Webb's data kept getting stronger. That forced astronomers into a difficult position. Do we adjust our models slightly? Tweak the timelines? Refine our assumptions? Or do we accept something far more radical, that our understanding of cosmic evolution might be incomplete? Some scientists proposed that galaxy formation happened much faster than expected. That early conditions in the universe were more efficient at building structure. Others suggested something deeper, that we may be underestimating the role of dark matter. Dark matter, the invisible substance that makes up most of the universe's mass, could be shaping galaxies far earlier than we realized. Acting like a hidden framework, guiding matter into place. But even that doesn't fully solve the mystery. Because Webb isn't just showing early galaxies. It's showing complexity. Rotation. Structure. Energy distribution. Things that should take billions of years to develop, appearing in a fraction of that time. And that raises a question that's hard to ignore. What if the early universe wasn't as simple as we thought? What if complexity didn't slowly emerge from chaos, but was already present in some form? That idea challenges more than just astronomy. It touches something deeper. Because for a long time, we've told ourselves a story about the universe. A story where everything starts simple, and gradually becomes complex. But Webb is hinting at a different possibility. That the universe may have been capable of complexity, from the very beginning. And if that's true, then the story of cosmic evolution isn't just about growth. It's about unfolding. Like something hidden, revealing itself over time. Meanwhile, another mystery began to surface. Webb's deep field images weren't just filled with ancient galaxies. They were filled with more galaxies than expected. Far more. It was as if the early universe was crowded, dense with structure, alive with formation. This wasn't the quiet, gradual beginning scientists had imagined. It was active, dynamic, almost aggressive in its creation. And that changes how we see everything that followed. Because if galaxies formed earlier and faster, then stars formed earlier. And if stars formed earlier, then the elements that make up planets and life also formed earlier. Which means the ingredients for life may have existed far sooner than we ever believed. That doesn't prove